Day 3, and this is probably one of the most important lessons for this chapter going forward to skills for next year. Right? How to multiply and divide fractions. You've done this before. You did it in grade 8. Yeah. And so that's what the rest of the chapter is. First 2 lessons were just like, hey, how do you compare fractions? How do you reduce it? Sort of a review of grade 8. And the rest of it's still grade 8 stuff, like adding and subtracting, multiplying, dividing fractions, and then math. That's the rest of the chapter. Of all those skills, multiplying and dividing is probably the most important of them. Right? Now, I went around and talked to the grade 8 teachers last year. There's different ways of teaching how to multiply and divide fractions. There's a technique that you use in grade 10, which I'll be teaching you this year. Right? Some of the grade 8 teachers may have taught this technique last year, but I asked them to. So if you were in my class last year, so this is going to be very familiar. If you weren't, the method you used last year still is valid. It just isn't as efficient and won't help you as much as grade 10. So let's get started. All right. Now, when we're multiplying numbers, often those numbers can have lots of negative signs. Our final answer is either going to be purely positive or should have one negative sign on it. Right? And we cancel out negatives by making them pairs. So it doesn't matter if you're multiplying or dividing. It's the same rules as before, right? If we had 2 signs that were positive or 2 signs that were negative, the answer was always positive. Positive, positive, positive. And if the signs were opposite from each other, it was negative, 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 right? This works great if you only have 2 numbers, right? But what I really want you to realize is, hey, sometimes we have more than 2 numbers, or more than 2 signs going on. Right? 2 negatives pair up to make a positive. That's what you really should be thinking about it. Right? So if you have an even amount of negatives, they're all going to pair up and cancel each other out. But if you have an odd amount of negatives, they can't pair up evenly. So there will be one lonely negative left over, so the answer is always going to be negative. Right? So that's the main skill I want you to know. Like, it works for this one too, right? We have an even amount of negatives here, 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 here. All positive. We have an odd amount of negatives here and here, right? So over here, just a reminder of simplifying. It's all the same fractions, so the answer is all going to be 1/2. But the question is it positive 1/2 or negative 1/2? So let's just put in a whole bunch of 1/2s for each one of these, and just then decide if it's going to be positive or if it's going to be negative. All right? So put in the 1/2, and then count the negative signs. So the 1 in the top left-hand corner, right? Is it positive or negative? This one. Just negative, just 1. Sometimes students get a little thrown off. It's only 1 sign, they make the sign disappear. It has nothing to cancel with. Now, you can put the negative out front here or with the 1, right? Those are 2 preferred locations. It doesn't matter where you put it. Next one over here, positive or negative? Positive. Positive. We have 2 negatives. These are going to cancel each other out, so our answer is going to stay positive. And we don't need to show a plus sign for that. All right, next one over here, answer positive or negative? Negative. Negative. 2 of them cancel each other out. There's 1 left over. Now it doesn't matter which one you show canceling out. Like I can pick these 2, or I can pick those 2. It doesn't matter. What matters is 1 negative left over, and we're going to add that to our fraction. Next one, positive or negative? Positive. Positive. These 2 cancel each other out. It doesn't change, right? And how about this? Positive. Positive. Right? That's it. Right? All right. So when we are looking at multiplying or dividing, there's 2 things we need to do. Is we need to multiply, then simplify, and also combine the signs, right? So the basic thing, the first thing you should be looking for is to combine those negatives. That's called finding positive pairs of your negative signs, right? So the first question here on the left-hand side, right, I'm going to write a fraction out. Is it going to be a positive fraction on our final answer, or is it going to be a negative fraction? Positive. right? We have two negative signs here. They're going to cancel each other out. So it's going to be positive. Okay. So now, the basic method of multiplying fractions, which you learn in grade 8, is to find out your new numerator is we multiply the tops together. 6 times 2 is 12. You multiply the bottoms together. 3 times 7 is 21. Then we look at our answer and see if we can simplify it, reduce it, lowest term. All those things mean the same thing. So we go 12 and 21. Is there something that can fit into 12 and 21? Thank you, Addie. 3 can fit into both of them. So you can. Then we go divide by 3, divide by 3, and that equals 4 over 7. Okay? Now, that's the basic technique that you should learn in grade 8. And if you like it, you can do it in grade 9. Right? But it's not the strategy you use in grade 9. So I'm going to give you a different strategy, which I'm hoping some of your grade 8 teachers showed you as well. Right? So now, when we're doing this, you'll get like half the marks to be able to come up with this number. The rest of the marks come from your ability to simplify. Okay? The only issue with this procedure is when we get numbers like this, for example, if we go grab my calculator here, we multiply the tops together. Where's my mouse? I go 64 times 42. That would be the number on the top. I go 96 times 60. That'd be my number on the bottom. That's really big numbers to simplify. That's a hard task to do. All right? So what we do is, instead of simplifying at the end, the other method is to simplify before we even begin our multiply. Okay? Simplify before we even begin our multiply. And then we're multiplying smaller numbers. And everything just stays smaller. And that technique works really well for fractions and other parts of math later on. So that's why I really want to show you this year. And if you had me last year, hopefully this is coming back to you. It's reinforcement. Right? So the other method, so going back to here. All right? So just exact same as the previous question, right? The two negatives cancel each other out. So our last step was, hey, look at the top number, look at the bottom number. Is there anything that divides and makes it smaller? Instead of doing that at the very end, we're going to do that at the beginning. All right? We go. So I'm going to draw here a little template of what a fraction looks like. So we have a fraction like this, 2 in brackets, a little fraction line. So we go compare the top and bottom here on this fraction, compare the top and bottom here on this fraction, and you go, can I make it smaller? So you look at this 2 and the 3. Okay, is there anything that can divide into the 2 and 3 here to make it smaller? No, they're both prime numbers. They can't get any smaller there. And you go, okay, is there 6 and 7? Is there anything that can go into there? No. So that's pretty small there. And here's the other thing. So you look up and down like this, but you also look at this top versus this bottom. You look in the cross direction as well. You look in this direction as well. You go, okay, can I fit something into 2 and 7? No, those are pretty small. How about 6 and 3? Can we go this way?
Yeah.
Yeah, and what number can we fit into there? Each 3. So what we're going to do is we do the dividing at first. We go, okay, I can divide both of these by 3. And we do this by pairs. So, okay, I can cross off one on the top, one on the bottom. They both can be divided by 3. So I go 3 divided by 3 in my head, or use a calculator, is the number 1. So I put the 1 down. And I go 6 divided by 3. I put the number 2 down. And 6 divided by 3 is 2. Right? And now, it's small as it can be. Now we do the original first step. We multiply the numbers across the top. So we go 2 times 2 gives us 4. And you have 1 times 7 gives us 7. Oops. 4 over 7. Still the same answer as last time. And it may seem a lot more work than what you were doing in grade 8 with the dividing and stuff like that. Right? when the numbers get bigger, like the one I did with the 264 and the 96 and stuff like that, it's much, much easier. So that, show of hands, how many have you guys done this, simplifying this way before? Only about a third of the class. Okay, so we'll take it nice and slow, all right? Okay, let's skip this one for now and look at this one with the bigger numbers.
What was the answer for that last one?
4/7, just the same as the other one, right? So remember, this one, if you multiply the tops together, we'd get this. If you multiply the bottoms together, we'd get that. And then we'd have to ask to simplify that. And that would be a pretty big job to do. So we're going to do the other approach first. All right? So we have our fraction. Is our final fraction going to be positive or negative? Negative. There's only one negative sign here, so the final answer is going to be negative. I'll put a little negative symbol there. Okay? I don't have to worry about the signs anymore. I'm going to worry about making the numbers small. Top to bottom comparison. I go, okay, do you see or do you know of any ways to simplify this way or this way? I saw a hand up there. Yeah, Colin?
96 for 64 over 96. There is
16 can fit into both. And if you're not sure, you can use your calculator. You go 64. You go 64 divided by 16. If it gives you a whole number, it works. If it gives you a decimal, it doesn't work. Then I go 96 divided by 16, I get this. So I go, okay, we're going to pair these up. I'm going to divide both of them by 16. So 64 divided by 16, and you use your calculator for that. We did that here. 64 divided by 16 is the number 4, and 96 divided by 16 is the number 6. You go. So I'm going to write down 4 here and a 6 here. Okay. I look at those numbers and I go, hey, they're still even numbers. We can make them smaller still. So 16 wasn't as a number that fit, but wasn't the biggest one. So Evan?
We can do
2, right?
Yeah.
You were saying that? So
2 over 3.
So now we can clean this up again. So once you wrote a number here, doesn't mean it's done, it's finalized. It may be used again. So I can go, okay, I can divide both of these by 2 because they're both even numbers. So 4 divided by 2 gives me the number 2. 6 divided by 2 gives me the number 3. Okay. So that's 2 over 3. Let's make this one smaller. 42 and 60. Sam? 6. Because I know the better you are with multiplying, the better this is going to come. So if you're like, where are these numbers coming from? That means you probably need more practice with multiplying. So for me, the way I would do this, I go, hey, I know that 6 times 7 is 42. Those are my factors for 42, and those are the numbers I'm going to check to see if it divides the other things. I go, okay, 7 does not fit into 60, but I know 6 does. So that's the way that my mind works. So I go, okay, I'm going to divide both of these numbers by 6. So 42 divided by 6 is the number 7, and 60 divided by 6 is the number 10. Right? So now, that's as small as it can go this way. Now we need to look in the cross direction. Can we make it smaller going at a diagonal like this, or a diagonal like this? Addie, where do you see it?
2 and 10.
The 2 and 10. And
1 and 5.
so the 1 and 5. So the 2 and the 10 can be both divided by 2. So cross them off as a pair. 2 divided by 2 is the number 1. 10 divided by 2 is the number 5. Right? And that's it. That's as small as these numbers can get. Right? So now we multiply the tops, right, and you multiply the bottoms together. So on the top we have 1 and 7. You get 7. 1 times 7 is 7. On the bottom we have 3 times 5, which is 15. All right? So a bit more work getting there, but it is a lot nicer than having to simplify. Where did this thing go? These numbers. Right? So now, if you're struggling, yes, you can do the grade 8 method. You can multiply the numbers on the top. You can multiply the numbers on the bottom. Then try to reduce that number. This is kind of very big, right? So I usually won't have that big of numbers, but you will have bigger numbers in grade 9 than you did in grade 8. Okay, let's look at this question here. We started off with a harder one. Let's go for an easier one. Final answer, positive or negative? Negative. Only one negative sign here. So, oops. So it stays. We make it negative. All right. Compare tops and bottoms. So 3 and 4. Can this be made smaller this way? No. 2 and 3? No. Any diagonals?
Yeah.
Griffin, where?
3 and 3.
3 and 3 can be divided by 3. So that gives us 3 divided by 3 is 1 and 1. And 2 and 4, those can be divided by 2. So I pair those off and I divide each by 2. So 4 divided by 2 is 2 and 2 divided by 2 is 1. So that's it. Now multiply the numbers on the top together. 1 and 1 gives me a 1, and a 2 and a 1 gives me a 2 for multiplying. So the answer is negative 1/2. Okay? Okay. So we're doing the same thing as last time in grade 8, just multiplying. Instead of multiplying first, we're just doing the dividing first. All right. So now, if we have more than 2 brackets, it's still the same thing. Any top number can make any bottom number cancel out. All right? So the first thing we're going to do is look across all 3 fractions and go, is my final answer positive or negative? Thank you. Positive. We have 4 negative signs. So these 2 are going to cancel each other out. Then these 2 are going to cancel each other out. The final answer is going to be positive. So now, the last couple of examples, I did top to bottom first on each one of them. Sometimes it might be faster to do a diagonal first. You may see a diagonal that really fits easily into another bottom one, right? So it might be easier to do that. And you can compare this bottom and this one and this one and this one, or all the way across the 3 like this. You can do like that kind of comparisons too. Any top with any bottom. As long as everything's multiplying in between. If you see a plus sign and minus sign in between there, yeah, you can't do that. But everything here is multiplying. Remember, there's 2 brackets touching each other. That means multiply, multiply, right? So, do you see any top with any bottom that can be paired up and made smaller? William?
Oh, top and bottom now.
Yeah. Oh,
I don't know that I've seen.
no, you don't see it?
40 and 16.
40 and, sorry?
16.
Where's 40?
30, 48.
Oh, 48. And what can they be divided by?
8.
So they can be both divided by 8.
16.
Oh, he said 8, so I'm going to go with that first, okay?
But
Right.
16 works, yeah.
16 does work too, right? So if you fit it in 8 times, right, so that's 6. So now, the reason why I went with Bill Judd, and you may have a different opinion, that's fine. When you can go all different orders, but if you get it down to the smallest thing, we will have the same answer at the end. All right, so now, Diljo and Griffin saw right away, hey, we could done it by 16, right? Because you have 2 even numbers. So do you want to make it smaller now or save that for later? All right?
I just made it smaller now.
Make it smaller now, so we can divide both of these by 2. So 2 divided by 2 is 1, right? 6 divided by 2 is 3. And that's the normal process, right? You do this, you go, hey, okay, something fixed, it worked. So you write the numbers down, you look at it, you go, wait a second, they're still even numbers. I could have done something a little bit bigger, right? So that's just normal. You're not going to normally always get the biggest number. All right, so you got those ones. Do you see any other pairs that work? William?
20 and 30 divided by 5.
Yeah, is there a bigger number? 10. So pair these up. 20 and 30 can be both divided by 10. So this leaves a 2 here and a 3 here. Anything else? Evan? Ev. How do we go that?
15 divided by 2 and 10 divided by 2.
Nope. 2 does not fit into 15. There. 5 does, yes.
That's the one I was looking
Okay, good. So
at the bottom.
pair these up. So notice I'm crossing them off as pairs. Then I'm doing the division. So 15 divided by 5, 3. 10 divided by 5, 2. Right? 5 fits in 10 twice. Okay? Now, just because we wrote in some new numbers down doesn't mean they're out of the game. Oh, you already got it?
Yeah.
Huh? Any other canceling? Colin?
3 and 3.
3 and 3. Those can be divided by 3. Gives us a 1 and a 1. 2 and 2. Thank you. 2 and 2 gives us a 1. Notice I picked this 3. I could have picked that 3. It doesn't matter which 3 I picked. All right? Just a 3 on the top cancels the 3 on the bottom. All right? So now, all we have is a bunch of 1s left on the top. We can't make 1 any smaller than 1. So that's it. We're at the lowest we can be. So on the top we have 1 times 1 times 1, which is the number 1. On the bottom we have 1 times 3 times 1, which is 3. All right, so it takes a little bit of work, but it's doable. All right. Now, the biggest mistake, and I mentioned this in my grade 8 class, I'm hoping you remember this, is sometimes people try to make 2 top numbers simplified, or 2 bottom numbers. It's a top and bottom pair. So you're allowed to go up and down? Yes. You're not allowed to go left and right? No. All right? Yeah. I told you that last year. Not that you needed, because you've forgotten it. Right? So yeah, left and right, no. Up and down, yes. All right? Okay. So that's multiplying. On to dividing, which is just like multiplying. Oops, that jumped. Make that smaller. Oh, that's jumping around. I don't like that. Let's go over there. There we go. All right. All right. So, last year, did we ever divide fractions? We had division questions, but we never did division questions. Steve? Yeah, go ahead. What did we do instead of division questions? We did some sort of changing. You guys remember this? No? A lot of blanks there. Remember what I was adding? No? Colin?
Keep the first fraction and then switch the
Yeah.
division to multiplication and then flip numerator and denominator.
Yeah.
for the second
So
one.
we did something called keep, flip, flip. You keep the first fraction, you flip the second fraction, and the division turned into multiplication, right? So that process of flipping that fraction is called a reciprocal. We mentioned that in the exponents unit, right? We have reciprocal, R-E-C-I-P-R-I-C-O-A-L. At least I think that's how you spell it. That's the flipping part. And in the exponents unit, that's what happened when you had a negative exponent, right? And that's what you're going to do a little bit more work of next year. You see the negative exponent, it means, hey, you flip that fraction, and it means it's a reciprocal, right? Right. Right, now, so we take this, you go, hey, we're not going to divide these fractions. We're going to keep the first fraction the same, turn that division into a multiple. I was going to bring it down for you a little bit there. There you go.
You put 16 instead of 6.
Oh, 16. Oh, thank you. 16(6). We turn that division sign into a multiplication sign, and we flip that second fraction, which means turn it into a reciprocal. All right. All right. So once it's like this, we just do the first page. Compare tops and bottoms and see if you can make it smaller. Squish them, squash them like Mr. Purcell does, walking around all the day. All right? Is there anything that can go into a top and bottom to make them smaller? 6 and 12 can be divided by what? 6. So both of these numbers can be divided by 6. Oh, sorry. Our final answer, positive or negative?
Negative.
Negative. Yep. So 6 divided by 6 is 1, and 12 divided by 6 is the number 2. All right. So 6 fits into 12 twice. Is there anything else?
No.
Right? Can we take these two 2's and make them smaller?
Yeah.
No!
Why not?
They're both on the bottom. We have to pair them up, top and bottom. Not two bottoms, not two tops.
I'm sorry.
That's okay. All right. That's it. So, multiply the tops together. 1 times 3 gives us a 3. Oops, that should have been pen. 3. Multiply the bottoms together. 2 times 2 gives us a 4. Our final answer. Now, I gotta say, hey, check your final answer to see if it can be made smaller. Because sometimes when you're doing these, you may miss a simplification in the crossing off. So always check your final answer. Say, hey, can I make this smaller? Because you may have missed something. All right. So always check this out. Okay, this can't be made any smaller. All right. All right. The one more step to make it more difficult is I can give you mixed numbers. So if I give you a mixed number, that adds an extra step onto what we're doing. Is we need to get rid of those mixed numbers by making them into improper fractions. So you go improper fractions. Right? We do this before you do the flipping stuff. Right? Change everything to improper fractions before you do any kind of flipping. All right? So the first fraction. So remember, the denominators do not change. It's the numerators we got to change here. So, first fraction, what should the numerator here be? 3. 2 times 1 is 2, plus the 1 is the 3. Remember, we ignore the negative sign when you do that. We multiply, then add 3, and put the negative sign on.
3 over 2.
Yeah, negative 3 over 2.
And then 11, negative 11 over 4.
Negative 11 over 4. So 4 times 2, multiply is 8. Add the 3 gives us 11. Negative 11 over 4. Okay. So now that you have all the mixed fractions going, now we do the flip. Yes, Sam?
I get your water.
Yeah. So, second one. Right? First fraction stays the same. Oops, that didn't jump the right way. Let's go backwards one more time. Will it let me? There we go. There we go. So the first fraction stays the same. We change the dividing sign to a multiplying sign. The second fraction does the flip. And just keep the negative sign on the top. Okay? You don't need to take it to the bottom. So, now we're going to do our cleanup. Final answer, positive or negative?
Positive.
Positive. We have two negative signs. They'll cancel each other out. So these cancel each other out. Okay. Comparing tops to bottoms. Is there any way? Going vertically or diagonally? Skylar, is there anything that can be made smaller? 2 and 4? Yes. They can be both divided by the number 2. So you go cross, cross, off of a pair, and then do the division. 2 fits into 2 once. 2 fits into 4 twice. 4 divided by 2. Is there anything else? No, a lot of people shaking their head. That's it, right? So you multiply the tops together. This times this gives us 6 over 22. This times this gives us 22. 6 over, not 22, 11. 1 times 11 is 11. Yeah. All right. Okay, let's have you do some practice. Let's have you do the top two. I'll give you the final answer. All right? How you do the top two, then we'll do that big 3 chain one together. All right? So here, if you simplify this and you get it down to its final answer, it's going to be 15 over 8. And you simplify this one to its final answer, it'll be negative 2 over 5. So let's see if we can do those two. All right? Okay. I'm glad that most of you guys are getting these. All right? So the first question, you flip the second fraction. Gabe, have a seat. There is no simplifying that can be done. That's fine. Sometimes that's the case. So, multiply the tops together, you got 15, the bottoms give you 8. The second fraction, all right, you flip that fraction and you have 12 and 6 can be both divided by 6. So that's 6 divided by 6 is 1, 12 divided by 6 is 2. Multiply the tops together, 1 times 2 is 2, and 1 times 5 is 5. Okay, and that's it. Okay, I think we'll stop there. We use the other one as a warm-up for next day. All right? Then right before the assignment. All right.